All right, so thanks everyone for coming out tonight to watch this little presentation here. So I'll be talking to you all about some research that we plan on doing in the Midwestern United States and down in the Southeast, hopefully here in the future. And we're actually looking for potential volunteers to help out with some of this work here in the future, but talking about radio and how we're using that with our wildlife research, specifically with bats. Let's see if we go forward here. There we go. So a little bit about me first. So I'm Dr. Reed Crawford. I'm a postdoctoral researcher in the Department of Natural Resources and Environmental Sciences at the University of Illinois, Urbana-Champaign. So I recently graduated with my PhD in ecology, evolution, and conservation biology back in May of 2025. And before that, I did a master's in biology at Eastern Kentucky University down in Richmond, and also a bachelor's in biology at Indiana State University. But for the past 10 years, I've been doing research specifically focused on bats, bat migration, bat ecology, bat use of bat houses, and things of that nature. And I've done all of this work with the lady there on the right, Dr. Joy O'Keefe. So she's a pretty big bat researcher all throughout the eastern United States. She's actually had a few projects in Tennessee. If you're familiar with Arnold Air Force Base in South Central Tennessee, she's actually done a good bit of work there as well. So bats are an incredibly diverse order of mammals. So there are over 1,500 species around the world, comprising about a fifth of all mammalian diversity. And here in Tennessee, we actually have about 16 different species of bats, give or take, depending on who's passing through the state at any given point in time. Bats are also incredibly diverse in terms of where they're living at. So a lot of people have this stereotype of bats is that they're always living in caves and dark places and things like that. That actually is true for a variety of species. So we do have some cave obligate bats that spend all year in caves. But for the most part, our bats are just using caves during the winter to hibernate. But during the summer, these bats are moving out on the landscape and primarily living in different types of habitats supported by trees. So things like cavities and live and dead trees, the peeling bark on dead trees, bats will crawl up underneath that and form large maternity colonies during the summer where they'll communally raise their pups together. And also things like foliage and sphagnum moss. Bats will actually hang out inside those foliage and moss clusters and actually hang out there during the daytime. We also have a variety of bats that'll look for these bare rock faces and cracks and things like that and live in there too during the summer. But bats are also incredibly valuable economically. So bats can consume over half their body weight in insects every night. And this can save farmers as much as $3.7 billion in the United States per year in pest suppression, so avoiding crop damage that would have otherwise happened as a result of not eating those different insects. But bats, in a lot of cases in the United States especially, are really in trouble and are declining pretty severely. So introduced disease is a major threat to bats. So one you may have heard of is called white nose syndrome. So it's an introduced fungal pathogen that was introduced from Europe and Asia. And this fungus attacks our hibernating bat species. So essentially when these bats are hibernating, their metabolic rate slows down a lot. So they're trying to conserve fat until they can get through to the spring and start getting bugs to eat again during the summer. But this fungus will actually grow on the bat's exposed skin. So like you can see here, it'll grow on their muzzle, it'll grow on their ears, and it'll grow on their forearms and wing membranes. And this fungus essentially is eating or irritating the surface of their skin. And this will wake those bats up more often than they normally would during hibernation. They actually end up burning through their fat stores and starving to death during the winter. So this disease has killed over 6 million bats in the United States since its introduction in 2006. Another major threat to bats more globally is habitat loss, so deforestation and things of that nature, because bats do rely heavily on trees to live in and raise their pups. This is less of a problem now in the United States since most of the deforestation has already happened in the early 1900s, and there's a lot of reforestation that subsequently happened throughout the United States. But lastly, one more emerging, more recent threat is actually wind energy development, which has been a major impact to bats as well as birds. So wind energy is a growing threat to bats. So in the United States, approximately 500,000 to 900,000 bats per year die from collisions with wind turbines. So this can either be direct collisions with the blades or the poles, or actually getting too close to the blades and the airspeed is fast enough that it causes a really quick air pressure change that can actually cause the bat's lungs to hemorrhage, and they'll essentially bleed to death from the inside from that. And this is a major threat to a variety of species, including our cave hibernating bats, but we also have a variety of migratory species within the eastern United States. So our migratory bat species are especially at risk. So we're looking at three species primarily that will occur here in the eastern United States. The eastern red bat up in the top right, the silver-haired bat in the left, and then the hoary bat down there in the bottom right, which is our biggest bat species that we would have out here in the east. And these bat species don't actually hibernate during the winter, so they'll move north during the summer when it's warm, potentially up into Canada. We don't exactly know where these bats are actually going to. And then during the winter, they'll actually move farther south. And we have no idea actually where their wintering locations are exactly either. But because these bats don't hibernate, we have no idea what their population size is. So typically for our hibernating bat species, they all congregate in just a handful of caves, and we know where those caves are. We can go into those caves and photograph them and count them and things like that. And we can get really accurate estimates of what the population size is. But because these bats don't congregate and they don't hibernate, we have no way to count them effectively, so we'd have no idea how many there are. And these bats are really susceptible to being killed by these wind turbines because they are flying long distance, presumably across the entire continent of North America, and they'll encounter lots of wind farms when they're doing that. So for instance, it is estimated that between the years 2000 and 2011, as many as almost 300,000 eastern red bats were killed with these collisions at wind turbines. So we don't know if this is a sustainable level of mortality, given we have no idea what the population size for these bats is. And approximately 7,900 more bat mortalities per year are expected with each gigawatt hour of wind energy production added to the grid. So, for instance, in 2023, it was around 6.4 gigawatts were added to the US grid. So you can multiply about 8,000 by that number. And that's how many additional bat mortalities you could expect that year. And so we know really little about when and where our bats are migrating to, if they're using specific migratory corridors, or if they're just sort of scattered randomly across the landscape. So bats are really small and they're active at night, so they're very hard to observe. They're not like birds where you can go out during the daytime and see them flying and see the big flocks and things like that moving across the landscape. And generally speaking, our bats are too small for things like GPS transmitters. So something that you can put on like a deer or a larger animal and get pinpoint locations on where it is that'll send to a satellite. Most of our bats are too small for that. So only one of our species this has been done with, this is the hoary bat, which is one of our larger bat species, can actually carry some of our smaller GPS tags. These weigh about 1.5 to 2 grams, these tags, and they're typically glued or sutured to the back of the bat. But the trick is here that these tags are still too small that they can't upload their data to a satellite. You actually have to catch the bat again a second time to download the data, which can be really hard. But this figure on the right is an example of a hoary bat that had a GPS tag in California, and it moved in sequence from 1, 2, 3, 4, 5, 6, all over Northern California into Oregon, into Nevada, before they recaptured this bat. So just getting a general idea for how far these bats can move over the span of a couple months or so. So if we know when and where these bats are migrating, we can potentially develop strategies to prevent mortality. So we can say, don't build wind turbines in this site if they're focusing in on key habitat types, or if there's specific time periods when these bats are really actively migrating, we can say potentially shut off these wind turbines or temporarily curtail them at night to allow these bats to pass through, and then you're essentially good to go after that. So radio can really help us when we study bat movement on the landscape. So something really common that we've done in the past to track bats to figure out where they're living during the daytime or where they're eating at night is to use VHF, which is just very high frequency radio transmitters. And there's an example of a few of these here on the right. So for bats, they're really tiny transmitters. Just have a little tiny battery that powers them and a really long antenna that sticks off the back. And typically with this type of transmitter, you would trim the fur on the back of the bat between its scapulae, and then glue that with like a surgical adhesive or surgical cement. And that would typically last for about 10 days to a month before it falls off. More recently, people have been messing around with putting dissolvable sutures to attach these radio tags, and this achieves a longer term deployment of potentially 100 to 200 days. So we can get much longer data collection from each individual. But these radio tags are typically using frequencies in the range of 150 to 164 megahertz. And they can actually be coded for individual tag recognition. But essentially, what I do for a lot of my job, not looking at the migration of bats, but just trying to find what trees they're using locally during the summer, is you use something like a 3-element Yagi antenna that you can hold in your hand and some type of receiver like this ATS R410. And that'll essentially pick up the pulses from this bat. And it's essentially a game of hot and cold, figuring out where the strongest signal is and being able to triangulate it down, reducing the gain on your receiver until you can get close enough to the tree to figure out where the bat is. But in terms of coding, so this is an example how that's done, so we can figure out individual recognition from the tag, so we know which bat. If we put out a bunch of transmitters with the same frequency, we can figure out which individual we're looking at. So these radio transmitters will put out a burst of pulses. So this whole sequence you can look at as a burst, and there's 4 individual pulses in this example here. And the time between those individual pulses can be used to encode individual information. So you have a receiver that can record this information. It can figure out which tag it was, and you wrote down which tag you deployed on which animal, so you know specifically who you're looking at. So tracking migrating bats poses a variety of challenges, though. So it's not feasible to track these bats by foot or by car because they can travel linearly across the landscape much more quickly than you could by car or on foot. And they're covering really large distances, so sometimes hundreds of miles. You can potentially track bats by airplane and do migration studies by airplane, but this is very expensive to do. You can only track a limited number of individuals at a time with a plane. And so there's one solution that's really come about to help us tackle this issue of tracking migrating bats and figuring out where they're going. And it's this MODIS wildlife tracking system. So MODIS is this international organization focused on facilitating the tracking of animals around the world through building a collaborative network of researchers and automated telemetry towers. So MODIS works off of these individually encoded radio transmitters and a network essentially of automated telemetry towers or automated radio towers essentially. And so those towers are all tuned to the same specific frequency, and you put out a bunch of encoded tags at that frequency, and these towers will listen for those tags, record the individual encoding from that tag and the timestamp so you know where that animal was on a specific date and time. And this has been used to track over 60,000 animals so far around the world. Primarily, this has been used for birds, but it's starting to get more popular for using this to track bats and also some insects as well. And this is just to give you an idea of what the MODIS network looks like right now. So these purple dots and yellow dots and blue dots all represent automated telemetry towers that are tuned to the frequency. These are all 164.380 is the MODIS frequency that they use for tracking wildlife. And all of those tags that you put out are individually coded specific to the individual animal you put it on. So there's really good coverage in a lot of places, but there are gaps that we're trying to fill in to get better spatial resolution. So looking at how these MODIS towers operate, so you essentially have these things can take a variety of different shapes and sizes and architectures, but essentially you have some sort of mast and you mount directional Yagi antennas on top of that. So typically a 9-element antenna, and you point those in a variety of directions. So typically for our study, we're just looking at pointing these east and west so we can get bats that are passing by as they're migrating north and south. But you can put antennas in all directions here as well. And then you have your tower, your mast, which goes down to a power supply. So ideally, you would be hooking this up to a building and can directly plug it into a wall. But if you're a more remote state or a remote site, you can hook these up with a solar panel and some deep cycle batteries to help power it. And then in a tote, typically, or in some waterproof case at the bottom, you'll have some sort of receiver station. So typically for these MODIS towers, they're using a cellular tracking technologies sensor station, which is what they build to help collect MODIS data. Or you can build what's called a sensor node with a Raspberry Pi computer for about $600, and it can do the same thing. But those receivers will store all of the detection data from those animals if they fly within range of that tower. So depending on line of sight and how tall your tower is, how many antennas you put up, you can be looking to get at a max about a 15-mile range is what they estimate at MODIS for these towers, but it can vary quite substantially. And then for downloading data, so you can either manually download data if you're at a really remote field site, but ideally if you're at a building, you can either hook up your sensor station to Wi-Fi or to an Ethernet hookup, and these sensor stations can actually automatically upload data to MODIS. So this is just a quick figure of a pipeline of how these data are processed. So your detection data are stored on a CCT sensor station, and you either automatically have it uploaded if you have an internet connection, or you have to manually download it and upload it to the Modus server. And then it's automatically processed by Modus, depending on which type of radio tag you have. And then it's made available on the Modus website database. And all of this data is open access. So any detections you get on your specific tower or any tower across the country, you can download those data, look at it, and see what animals have passed through there. So this could be bats, this could be birds, this could be insects. So anyone who's putting out tags, their detection data will show up. And if it goes by one of your towers, then you'll be able to see that. And so for our lab, we're looking at studying the migration of the eastern red bat. So this is one of those species that's heavily impacted by wind energy development. We essentially have no data on when this bat migrates and where it migrates to, and if it has specific migratory corridors that it uses, or if it's just moving randomly across the landscape. So if we're trying to prevent mortality from wind energy development, it'd be really important to know, are these bats using rivers as major migratory corridors similar to birds, things like the Mississippi River Flyway? Or are they moving across forest patches or open lands and things of that nature? Are there specific wind patterns? So maybe they want a tailwind when they start migrating, or maybe they're looking for warmer temperatures. So if we can key in on these things, we can provide better guidance to these wind energy facilities about where they should site their weather or their wind energy stations, and when they should consider turning off their stations or the wind turbines temporarily to allow those bats to pass through to prevent those mass mortality instances. And so essentially what we're going to be doing, so this project's going to take place presumably starting in spring of 2027 and then end in 2030. So we're trying to go for about 3 years of work studying the migration of this species. And we're going to be doing this work primarily in the Midwest and the southeastern United States. So hopefully we're going to be mistnet capturing eastern red bats at ponds, streams, and forest roads. So anywhere out in the open or in the wild that we can get these bats. And mist nets are essentially a fine mesh net that you string between two 20-foot tall poles. The mesh net runs from the ground all the way up to the top of the pole. And you essentially cross a corridor that bats would be flying through. The mesh is very, very fine, so the bats can't pick it up with their echolocation. They'll fly into it and get tangled up. Then we can walk up and pull them out of the net and be able to attach our radio transmitters. So once the bat's in hand, we can take all sorts of measurements of the bat, give it its sex, age, reproductive condition, that sort of thing. And we can attach our radio tag to the back of the bat and then release it. And then after that, it's essentially just looking at the automated telemetry network and allowing that network to track the bat's movement through time. So we're going to be catching bats in the spring and fall. We hope to be able to put transmitters out on 30 eastern red bats each spring and fall for those 3 years. So we're looking at about 180 individuals we're trying to get data from. And this is just a quick example of what some of these data look like. So these data are open access on the Modus website. So if you're interested in going there, you can check it out and type in, any species you're interested in. If it's been tracked on there, you'll be able to pull up those data. But these are data from a silver-haired bat that was initially tagged up just south of Toronto up in Canada. And this took place over about a month. This is its movement. So you can see the track of the towers this bat was detected at as it's made its way out to the East Coast. And then the tag eventually fell off, or the battery died or something like that, and they no longer got any data on it. So you can see these really cool long distance movements by these bats. And because we're going to be putting out these transmitters with sutures, we should be able to get 100 to 200 days of data. So to get more long-term data about when these species are moving. So hopefully catching spring and fall migration to figure out where they're going, as opposed to these shorter-term deployments where you only get a partial window of what's happening. And because we'll be attaching these transmitters to a bunch of individuals, hopefully we'll be able to detect patterns in the direction that these species are going, their proximity to these major waterways or forest patches or open areas and things like that, to be figuring out what they're doing. So yeah, what we hope to gain from this research is detailed information about when and where these bats are migrating and what habitat features might be important. So we're really thinking these rivers could be important corridors for these bats, but there are a variety of other directions and habitats and things that they could be using, and geological features that they could be using to migrate and use this orientation. We also want to know how weather influences migration timing. So because we know the dates and times of these movements and when they're detected at each tower, we can look at the weather data associated with when that bat is making those long distance leaps to new sites. And we can also figure out what areas in the eastern United States wind energy companies should avoid developing and what areas are safer for developing. So the safe sites that the bats typically aren't going to, those might be fine for development, whereas these more sensitive areas, they might not want to do that. And then for those turbines that are already in place in those sensitive areas, we can provide better guidance on when those turbines are going to be most dangerous for those bats. So with this, we're looking to hopefully expand the MODIS network in the southeastern United States so we can get better spatial resolution about where our bats are moving. So we're specifically looking at areas in western Tennessee here, so around the Jackson area and along the Mississippi River, as well as areas in northern Arkansas as well. We're hoping to put up more towers so we can figure out where these bats are moving to and if they are using the Mississippi River. So a lot of netting we'll be doing, some in Tennessee and a lot in Missouri and potentially some in Illinois as well. So hopefully we'll be able to see bats moving along these corridors and making these long distance movements in this area. But this is also where we're hoping to get volunteers, so people who have experience with radio and expertise. So a lot of you guys in here will know substantially more about radio than I do and have substantially more experience maintaining this type of equipment. So we're interested in finding individuals who would be interested in hosting a telemetry station on their property or at their house. And if you have access to power supply to hook it up to or Wi-Fi to manually upload data, that would be great. But if you don't, making an effort to download data once a month and be able to check on the tower and troubleshoot any issues that are having with it. And so what setting up a MODIS tower essentially looks like is we're going to be buying a bunch of equipment for this through a grant that we're hopefully going to be getting here in the spring. And you'll get a receiver station, a variety of Yagi antennas tuned to the MODIS frequency. Depending on the setup and the location, we'll be looking at some sort of master roam tower to put up at that site to support those antennas. And then depending on power supply, we're either looking at solar panels or directly hooking up to a building. And if you do have an internet connection, that'll facilitate automatic upload of data. And then essentially at that point, you just perform a maintenance check a couple times a year if you're not worried about having to go out and download data. But with that, we are looking for help to do this project and be able to collect great data on these bats. So if you are potentially interested in hosting a MODIS station at your property, feel free to shoot me an email at reeddc2@illinois.edu, or feel free to call my cell phone at 812-242-0117. So we're looking to start putting up towers sometime during the summer of 2026 or the spring of 2027, also during the winter of 2026, 2027 as well, depending on how much money we get and how many towers we end up being able to put up at that point in time. But if you do host a tower, all of the data is open source and available, so you can see all the different animals that have come by your property. And you can see not just the bats that we're tracking, but anyone who's doing research with wildlife. So there's lots of people across the country and up in Canada who are doing work with birds, bats, and insects that you'd be able to see as well. But with that, I'm happy to take any questions if y'all have any, and thanks for tuning in.
Thank you, Dr. Reed. I really appreciate you coming out and explaining. That was actually really interesting information. I'm not going to lie.
Yeah, cool.
So I do have a question.
Uh,
What are you looking at when it comes to a height on like those towers and stuff?
So typically, what we've seen is somewhere around 20 feet up to as tall as you can go. So we have some colleagues that do bird work here in Illinois, and they put these towers up on like water towers and grain silos and things like that. So you can attach them to a variety of things, and the higher the better, essentially, is what they typically say. So some of our colleagues have put these up along the Gulf of Mexico, and they think they've gotten detections from birds crossing the Gulf at about 60 miles is the farthest they've gotten. So that's what they think. I'm not too good of an expert at this yet, so we're just getting involved with MODIS at this point in time. So I don't know what kind of detection we'll have, and really mountainous areas too. It's probably very, very limited. But yeah, high line of sight is very good.
Awesome, awesome. Um, there was another question I had. That area of the state that you're looking at is very hard to get things out to. So,
Yeah.
um, you know, but we actually have a club in that area,
Mhm.
in Memphis. So we'll definitely send this information to them
Yeah,
and
yeah,
your
that would be
information
great.
because me and Michael both we were like, that's actually really interesting. So um, I didn't know. I've heard of Modus, but I never heard of like what actually it is. So to
Uh,
actually see it, hear it, that actually painted a very good picture. So thank you so much for coming and presenting tonight.
Yeah, no problem at all. Thanks for having me and letting me get this info out there. But yeah, if anyone's interested, yeah, feel free to share this around to anybody who'd be potentially interested in doing that. And yeah, we might be able to get help from the Tennessee DNR as well. We've been talking to them about putting up towers and where they think it would be most beneficial, and the Nature Conservancy in Tennessee as well. It's been involved with putting up a lot of Modus towers in the eastern part of the state. So yeah.
Good deal. Mike, you got anything?
Um, well, is this something that like, so if somebody just say like, I got an extra radio laying at home and I wanted to put something up, and I'm guarantee I'm not the only ham that has extra radios sitting on a shelf that aren't plugged in doing anything.
Mhm.
Um, but if this is something like, is this something that has to be coordinated through some sort of organization, or can anybody just put up a Modus tower and start feeding in data?
Yeah, so I'll have to dig into you would have to create a profile on the Modus
Sure.
website to register your device essentially. And I don't know
Right.
if you have to have a professional affiliation when you do that. I've never attempted to sign up that way. But you probably, as far as I'm aware, anyone can get on there, and if they have the equipment to do that, can register it with
Sure.
them. You have to download specific software and things like that. Like
Yeah,
the
of course.
receiver station is like the main thing. Everything else can be swapped out for whatever. But yeah, the receiver station will have specific software that you download and pick up to it. And then yeah, I wouldn't see why you'd have any problem doing that. And if they don't have it set up that way, you could it's run by an organization called Birds Canada, and
Hmm.
they'd be more than happy to get as many people as possible to be able to put up these towers
Gotcha.
for that. So
Yeah, I didn't know if it was something where anybody that had the interest could do it, or if there's
mhm,
more of a coordinated effort on where they want to focus efforts, so we're not getting,
mhm.
diminishing returns from having, six people in a 1 mile radius have towers up, and
Right.
you're not getting good data because it's all the same data.
Yeah, and I've seen people do that, and some of the bird people have done that at like a specific like park or wildlife management area, and they'll use like shorter range
Sure.
Yagi antennas, and they can get really fine scale movement where they know the direction of each antenna and they can triangulate the animals.
Very cool.
And they'll use that for like when like birds are foraging to figure out how much time they're spending in this patch of forest versus that open field versus the water or something like that. So you can put them up that way, and sometimes people put them up for short durations, then take them down at the end of their project. So
Sure.
yeah. But yeah, in this case, our grant would cover all the materials for it. But if you have something specific you were wanting to put up or volunteer equipment, that would also be great as well. So we could
Sure.
potentially allocate those resources to another tower somewhere else. So
All right.
yeah.
Very
Well,
cool.
that answered my second question. You said post. I was like, towers are expensive. So where's
Right.
so you said grant, where does the funding for this come from?
So we're applying for a variety of grants. So the first grant, if we get this money, would come from Tennessee Valley Authority, is a major supplier. So they do bat conservation grants essentially. We're also talking to Missouri Department of Conservation to do a long-term project there, which we'd want to expand towers to the south because the bats don't stay within the state boundary. And then we're also in talks we've been in talks with 4 different states. So Iowa, Missouri, and Tennessee, and Arkansas as well, potentially doing a multi-state. It's called a multi-state competitive wildlife grant. We have a bunch of states put forth money, and then the federal government will match whatever the state puts forward to fund a bigger multi-state collaboration. So, yeah, pending funding. So we'll see here in March about our first grant, and we have a couple more opportunities coming up after that. So, gauging interest and getting boots on the ground, essentially, if we can get this going.
Absolutely. Well, awesome. Thank you so much.
Yeah, no problem. Thanks for having me on. If you have any questions, feel free to shoot me an email or give me a call or whatever. So yeah, thanks so much.
All right.